3 types of angle relationships explained in 5 minutes. The 3 different types of angle relationships we will be working with are angles that are equal to each other, angles that are complementary, and angles that are supplementary. So angles that are equal to each other are generally vertical angles, where the 2 angles share a common vertex point and are opposite of each other, and they are equal in size. So if we were to write an equation, we would say that this angle A is equal to this angle B. Angles that are complementary have a sum of 90 degrees. And the 90-degree angle box here would be denoted in the drawing. When you write the equation for that relationship, both angle measures will be on the same side of the equal sign, and you will need to put a plus sign in between them and a 90 on the right-hand side. For angles that are supplementary, they have a sum of 180 degrees. So we would add angle A to angle B to make that half circle of 180 degrees. Let's take a look of an application and how we set it up. So in order to set up an algebraic equation, first you have to determine what type of angle relationship you have. It will be one of these 3. Each of these have their own specific format. So if 2 angles are equal, then the format is that one angle measure, whatever that math is, would be on the left side of the equal sign, and the other measure would be on the right. And the equal sign would be in between the information. For angles that are complementary or supplementary, the format is very similar. You would sum the 2 angles together and use the appropriate value on the right-hand side. Once you get the format set up, you can solve for that given variable, and if necessary, you can actually find the measure of the angle. Here in this example, we have 2 vertical angles that share a common vertex, therefore they are equal. We will take the measure of the first angle and put it on the left side of the equal sign. We will take the measure of the second angle and put it on the right side. We will then use our algebraic properties here and to solve for the value of x, which in this case would be 30 degrees. Which makes sense because 5 times x would be 5 times 30, and that would be 150 degrees, which is equal to the other angle. Another relationship you could have are complementary angles, 2 angles that sum together to make 90 degrees. That means that the answer will be 90, but these 2 algebraic expressions will be on the same left side. And in between, we have to put a plus sign. Now I can use my algebraic solution properties here to get 10x equals 90, divide both sides by 10, and get the value that x is equal to 9. In the third example, our 2 angles form a perfect straight line, right here. Those angles are supplementary. Again, you will put a 180 on the right-hand side, and you will put these 2 algebraic expressions together on the left-hand side, and you will need to add a plus sign. These are not like terms, so I'm going to use the subtraction property of equality here to start isolating my x value. Now I'm going to divide by my coefficient. And now I have my value of x. Another question that you could see are expressions that actually have sum or differences in them. Again, I have a pair of vertical angles here, and vertical angles are equal. So the expression for the angle on the left will go on the left side of my equal sign, and the expression for the angle on the right will go on the right side of my equal sign. No 90 or 180 involved. Now I'm going to subtract 8x from both sides to isolate my value of x here. 31 is equal to 8x minus 9. I'm going to add 9 to both sides, giving me 40 is equal to 8x, and dividing both sides by 8, giving me x is equal to 5. In this last example, we're actually asked to go one step further. After we find the value of x, we then are going to find the measure of each of these specific angles. The first is the measure of SQR, S to Q to R. The second will be RQT. RQT. So first, I have to define the relationship, and these are supplementary. Two angles that add together to make 180 degrees. So 10x minus 22 plus 3x plus 20 is equal to 180. Combine like terms, 13x minus 2 equals 180. Add 2 to both sides. 13x is equal to 182. Divide by 13, and we get x is equal to 14. Now I need this value, but it's not the answer to the question. So the measure of angle SQR, which is written here in blue, is 10x minus 22. So what I'm going to do now is erase and replace the value of x with what I found, 14. So 140 minus 22, which makes the measure of angle SQR 118. And now I'm going to find the measure of RQT. The measure of RQT is 3x plus 20. Erase the value of x with the value you found, and then compute 3 times 14 plus 20. So the measure of RQT is 62. And if we add these two together, 118 plus 62, I get 180, just like I thought I would. And that concludes the tutorial.